All right, this is problem 3 from round 5 of this week's problem set. This is a good linear and angular motion problem. So it says a belt is moving counterclockwise without slipping around two circular pulleys. P with radius 2 feet, Q with radius 30 feet. I might just stop there and label, because as soon as I see something I can label, I do it. So we know that circle P has a radius of 2 feet. And Q is a radius of 30 feet. I'm going to put it here for now. Let's just keep reading. So it says if pulley P turns at K revolutions per minute and PQ is 100 feet, a mark on the belt at point A moves past point B in 1 second. A and B are points of tangency of the belt with pulleys P and Q respectively. Using the approximation pi equals 22/7, compute K to the nearest 5 RPMs. So I might finish drawing this diagram in a way that might be helpful. So we know that this here is 2 feet as well. And since this whole distance PQ is 100, I think I'll label the interior here from here to here as so that's 68, I believe, right? 68 feet. Okay, and we know that in 1 second, right, when these are rotating, it looks like point A moves past point B in that 1 second. And we are expected to find K, which is the rate at which P is revolving. Okay, so I'm going to zoom in on this picture on the next slide. Okay, so don't forget we're trying to find, right, this is rotating at K revolutions per minute. And we're trying to find K, and we're trying to find K to the nearest 5 rotations per minute. So the other thing I didn't label in this diagram was remember that it takes 1 second, right? From this point A, it takes 1 second for A to get to B. So it'd be nice to know that distance AB. So if you draw in a parallel line here, a line parallel to AB, I'm going to do that. That'll make a rectangle. I'm going to call this point D. And that allows me, so because it's a rectangle, I can say that this here is a 2, and this therefore is a 28, because that's the radius of the circle. Now I can use the Pythagorean theorem. So I'm going to say, so we know that QD squared plus PD squared is equal to PQ squared. And QD squared is 28 squared. PD squared we were trying to find, and PQ squared is 100 squared. Okay, and so that means that PD is equal to the square root of 100 squared minus 28 squared. So this problem on a problem set is done without a calculator, so you might notice that you can take out a well, so 100 squared would be 4 squared times 25 squared, right? So it's 4 squared times 25 squared. I'm going to do the factoring as I go. And 28 squared is 4 squared times 7 squared. So that allows me to say that this is equal to, let's just get some space here. So this is going to be 4 times the square root. So 25 squared is 625 minus 7 squared is 49. So the 625 minus 49, that's 576. So 6. So it's 4 times the square root of 576, which, as it turns out, is 4 times 24, which produces 96. So now I know that AB is also 96, right? So AB is 96. I'll record that over here. Right, because AB is congruent to PD. So now we know that it takes 1 second for A to go to B. So it takes 1 second for point A to travel 96 feet. Okay, but in order for A to get to B, right, we need pulley P to be rotating, and you can imagine that pulley P is going to have to be rotating out its circumference 96 feet in order for A to get out to B. So essentially what we're saying is we know that one rotation, or one revolution rather, so we know that in one, it's 96 feet per, right, 96 feet per 1 second, right? It takes takes 1 second for A to get to B, so it's going 96 feet per second. So we want to convert that to revolutions per minute, okay? Because as we said, pulley P over there is going to have to rotate out its circumference. So we need to know how many revolutions per minute that takes. So I'm going to do this by using a little conversion. And I'm going to convert seconds to minutes, right? Because we want minutes down here at the bottom. So we know that there are 60 seconds per minute. Okay, so now I have my answer in feet per minute. We need to know we need to figure out a way to convert feet, which is like a linear distance, at least in this diagram, considering AB. We want to convert that to an angular or a rotational speed, I'm fumbling a little here. Feet per minute we need to convert to revolutions per minute. So I'd like to convert feet to revolutions. That's what I'm trying to say. So 1 revolution of pulley P is equal to its circumference. Well, its radius is 2, so its circumference is 4 pi. Okay, so what that means is we can multiply this by 1 revolution divided by, so we can't use pi. In the previous slide, you'll notice that they wanted us to use 22 sevenths. So that's 4 times 22 sevenths. So we're going to use 88 sevenths feet. All right, and so now we will have our answer because we've got our units, revolutions per minute, and we just need to clean it up. Revolutions per minute is the units, and K is what we're trying to find there. So we got to do a little bit of multiplying here. So this is 96 times 60. Now dividing by 88 sevenths is the same as timing by 7 over 88. Okay, so let's do 96 times 60 and times 7, and let's think of this 88 as 8 times 11, because I know, just going to move things around again, because I know that 8 goes into 96 actually. So 8 goes into 96, 12 times? 12? And 7 times 12 is 84. So now I'm doing 84 times 60 divided by 11. At this point, we might just do 84 times 60 out. So 84 times 60 is, 4 times 6 is 24. So it's 24 plus 6 times 8 is 480. Right, so that's, and then of course it was not really times 6, it was times 60, so really we've got 5,040. So it's 5,040 divided by 11, which equals, so 11 goes into 50. I mean, here it's just really the algebra here, or the arithmetic. 11 goes into 50, let's see, this is going to be 450. 8, and it's going to be 2 left over, so plus 2 11ths. Now we're supposed to round to the nearest 5 revolutions per minute. So 458 plus some change, this is going to get rounded to 460 revolutions per 1 minute. So that problem was really the arithmetic actually that made that problem annoying. But anyway, yeah, we got a good angular and linear speed problem for you there.